Hi students, welcome back to Physics for All YouTube channel. In today's session, I am going to explain about diffraction, the bending of light around an obstacle or small aperture whose size is comparable with the wavelength of the light, then it is known as diffraction. In order to understand about diffraction property, consider a light source, an obstacle and a screen. Now when light source is on, that light is going to incident on the obstacle whose size is equal to the wavelength of the light. Then this incident light at the edges of this obstacle is going to bend. This bending phenomena of light at the edges of obstacle is called as diffraction. Now this diffraction can be classified into two types. Number one is Fraunhofer diffraction and number two Fresnel diffraction. To see this Fresnel diffraction or Fraunhofer diffraction, we have to get one obstacle, one source and the screen. Now we can differentiate between the Fraunhofer diffraction and Fresnel diffraction. First one is we will discuss about the Fraunhofer diffraction. In the case of this diffraction, the source and the screen are placed at infinite distances from the obstacle, and because of infinite distance from the obstacle, here we have to use lenses. This diffraction can be studied in the direction of propagation of light. Here the incident wavefronts are plane wavefront. Now coming to the Fresnel diffraction, the source and the screen are kept at finite distance from the obstacle. Here, because of finite distances from the obstacle, lenses are not at all going to use. This diffraction can be studied in any direction. Here, the incident wavefronts are either spherical wavefronts or cylindrical wavefronts. Now we will discuss about differences between the diffraction and interference. This question is important for the university end examinations. Now we will focus on the diffraction. It is due to the superposition of secondary wavelets from the same wavefront. Now due to the diffraction pattern, we will observe the fringes. Now if we can observe the intensity of the fringes, these fringes intensity decreases as order is going to increase. Then in the case of diffraction phenomena, the produced fringes are having unequal widths. The last one in the case of diffraction is the intensity at the center of the fringes is not zero. Coming to the interference, it is due to the superposition of secondary wavelets from the two coherent sources. The intensity of the fringes remains same. That means we can check the intensity of each and every fringe. Its intensity is the same. In interference phenomena, the produced fringes are having equal widths. The intensity at the center of the dark fringe is zero. These are the main differences between the diffraction and interference.